Good afternoon. So I'm going to start with a couple of questions over here. How many of you are currently using a SIEM solution or have used one in the past? Okay. How many of you have faced issues with scaling your SIEM solution? It's a lot of hands. If you feel strongly, you can raise both hands. Awesome. All right. You're not alone. There are a lot of people in the same boat. With that, we're going to talk about scaling CloudSIEM correlation with the new pattern recognition rules engine. I'm Akash Karakia. I'm a security solutions specialist at Sumo Logic. In my career as a security professional, there are two words that keep coming up. First one, correlation. Secondly, scaling. You must have heard in our keynote, Sumo Logic is fully based in the cloud, delivering a true SaaS solution. And we bring in structured and unstructured data and convert it into insights based on users' context. I'm going to start with the quote over here by Ronald Coase, which actually applies to economics, but we're going to translate it to information security today. Torture the data enough and it will confess to anything. What do we mean by torture the data? You're going to identify your logs, you're going to capture it, you're going to collect it, you're going to isolate it, you're going to break those log messages, extract what you want, then you're going to aggregate it, join it. Finally, when you do this, when you torture the data enough, you will get a confession. The confession is your alert. It might be actionable, it might be not actionable. But what comes out of it is if you torture the data enough, you will get a confession. What is log correlation? You're bringing in logs from different sources and you're trying to establish a relation between these logs based on certain conditions, right? Your correlation could be based off user information or emails, hosts, URLs accessed, files accessed. In the end, you're tying your logs together based on certain conditions that you find appropriate to tie those log messages together. This over here is the amount of machine data that has been generated worldwide. In 2005, we were looking at 0.1 zettabytes. 2015, 12 zettabytes. This number is expected to grow to 163 zettabytes by 2025. 1 zettabyte is a billion terabytes. So we're looking at 163 billion terabytes by 2025. The point here is plan for growth. Don't build a SIEM solution that is sustaining the current data volume. Plan for 10 years ahead. The amount of data is growing. This number could be 60 or 600. 163 is just a projection. We do not know how much data we're going to have 10 years down the line. With that, we're going to talk about the new CloudSIEM rules engine. We're going to cover several components of the rules engine. Firstly, we're going to talk about filter expressions, geolocation enrichment, threat intel lookups. You can also build custom lookups, and then you can aggregate, join, right? So far we tortured the data. And finally, when you get a confession, we're going to use response actions to take action on the confession. Filter out events that are not of interest. Focus on the events of interest. This will help you scale your rule. The smaller the subset of data that you pass to the remaining part of the rules engine, the more scalable your rule is. Let's look at an example over here. This is a screenshot of a CloudSIEM rule. We have a filter label, which you can define. We call it E1. And then we have a filter expression, which a lot of you can tell this is looking for port scanning activity. What we are doing over here is we are filtering out events that are not of interest, right? We are looking at a small subset of data. This simple filter expression reduces your volume by 80%. That's an estimate. So you are only sending 20% of your data to the remaining part of the rule. This massively helps you scale your rules. Lookups. You can enrich your data with geolocation information, threat intel data from CrowdStrike, which comes out of the box with Sumo Logic, right? And you can also build your own custom lookups. The screenshot on top, we're looking at the CrowdStrike feed, we're matching it against the destination IP, and we're enriching the data with thread information. If you look at the filter expression, we are excluding every event that does not match our CrowdStrike feed. This brings down your data volume for the remaining part of the rule to probably less than 1% of the overall traffic. The next example, we are enriching the data with geolocation information, right? So we have the country name, region, and city that we're pulling out based on the event IP address. We're giving filter variables, right? That's custom. You can call it whatever you want. And then we're using that in the remaining part of the rule. This over here is a custom lookup, a lookup that you can create on your own. You can define the schema of the lookup. You can have a TTL, a time to live, right? In this case, it's 43,200 minutes, which translates to 30 days. Any data older than 30 days will be purged from the lookup. So essentially, you're maintaining historical data in your system for 30 days. I have created a schema with 3 columns, country, region, and city. In the next screenshot over here, you're looking at the same custom lookup being used in the rules engine, right? So we're pulling out the country, region, and city for every event that comes into the system. We're enriching it with geolocation information. And then that geolocation information, we're looking it up against the custom lookup, right? Now what I'm doing over here is I'm focusing on console logins in CloudTrail, and then the geolocation information that I got from there, I'm matching it against the custom lookup and checking is this entry already existing in my lookup? If it is, it's not a rare geolocation. If it's not, that's a rare geolocation, a geolocation we haven't seen in the last 30 days. Joins. You can join and correlate filtered data from the same source or different sources based on predefined join conditions, right? Let's look at an example of short-lived accounts. This use case is basically detecting accounts that were created and deleted by the same user within 24 hours. Any join rule will have 2 filter labels at least. My first filter label is E1, which is basically looking for the event where the user was created. My second filter label is E2, which is looking for the event where the user was deleted. Now we're going to join these 2 filter labels. And my join condition is based on the account ID. The AWS account ID needs to be the same. The source user needs to be the same. And the target account needs to be the same. Lastly, to scale this, we're going to have a within time operator which holds that information for 24 hours in this case. And if there's a delete user event for the same account ID, user and target account, it's going to flag it as a short-lived account. This number, you can change it. You can make it 1 week, 1 minute, 1 day, or 1 hour, whatever you find appropriate. Aggregation. When we talk about aggregation, there are 2 things that come to our mind, right? So there's count and there's count distinct. Let's take an example. My first count is how many people are attending this conference. That's a simple count. My second aggregation is how many people are attending this conference from each organization. Essentially, you're doing a count distinct on the number of people from each company, right? So let's look at an example. Spike in failed logons. This is our first example we spoke about. How many people are attending this conference? Simple count. We're looking at failed events in one login, and then there's aggregation fields for same values, and there's aggregation fields for different values. We're not using different values in this case. We're just going to do a simple aggregation on the event user ID. We're going to give it a threshold of 10, and the duration is 60 minutes. So if you see 10 failed logons from the same user within 60 minutes, we're flagging it as a spike in failed logons. The next example We're using aggregation fields for same values and aggregation fields for different values. The key difference over here is, in this case, we're looking for password spray attacks, right? An attack where a password is tried out on multiple accounts from the same source. It might not be from the same source, but for this example, it's from the same source. So what we're doing is we're looking at how many different user IDs saw a failed authentication event coming from the same source IP. This is a count distinct, right? Count the distinct user IDs and group it by the IP address. Again, we have a match count of 10, which is a threshold, and the duration is 60 minutes. Now, let's take a step back. We just spoke about torturing the data, right? We parsed it, we aggregated it, joined it, put it through a filter, and focus on the events of interest. Now, when a confession comes out, we're going to define a session. This confession is valid for this long. That's session actions. You can enable session actions, which gives you the ability to decide what you're going to do with the confession, right? You have the option to send out an alert on the first trigger and keep quiet on the remaining ones. You can decide what you want to do with the subsequent ones, right? Maybe for the first one you want to create an investigation. For the following ones, you just want to store that information somewhere. You can also have alerts on intervals, right? So if I have a 15-minute interval, I will get an alert every 15 minutes instead of being hammered nonstop. On session expiration, let's take an example of a denial of service attack. You're getting hammered with network traffic and your mobile phones or PagerDuty or email alerts, you're going to be hammered with alerts. With this, you can suppress your alerts. You can manage your alerts. You can decide what you're going to do each time the rule triggers. On session expiration, when the DDoS ends, you will get an alert. So you get an alert on the first trigger, right? When the DDoS started, let it run, and then you finally get an alert when the attack actually is over. So we got a confession. The next step is to take action on the confession. Your options are you can create a notable event, and I will talk about notable events shortly. You can modify lookup entries. You can directly create an investigation if it's an actionable confession. You can invoke a script. You can send out email alerts. You can invoke webhooks. It's your choice how you want to deal with that confession. So notable events. What are notable events? Think of notable events as a confession that you cannot do anything about it yet. You need more confessions to tie it together and actually have an actionable investigation, right? Notable events are stored in a Sumo view. You can query it anytime, and then you can use it in tier 2 or tier 3 rules, right? You can tie multiple notable events together to come to an actionable confession. This rule over here is taking an action, creating a notable event, right? I give it a name, description, severity, and along with that, I pass some information, including the username and account ID. Notice I've added an alias called correlation ID. That's my identifier for this notable event, right? I'm going to pass this correlation ID, which is hard-coded as spike and fail logons CloudTrail. I'm going to tag it to this notable event, and I'm going to use it at a later point. This is what your notable events look like. It's a view. You can query it in Sumo. And then notice we have the name, description, severity, all the information passed on in this JSON payload. This rule over here is now going to leverage and correlate the notable event to incoming messages, right? So we looked at spikes and fail logons. Now we're going to leverage that notable event, and we're going to look at successful brute force attacks. Essentially what you're doing is you're looking at a spike and fail logons, and within 60 minutes, if you see a successful logon from the same account, that could potentially be a successful brute force attack. So my first filter label is auth fail. Notice I'm specifying the correlation ID to identify the log messages from the notable events. My second filter label is auth success, which looks at all the successful authentication events that are coming in. The next thing I'm going to do is I'm going to join it. I'm going to correlate the notable event to the new log messages that are coming in, and I'm joining it on the username, right? Your auth success alternate ID in Okta is your username, and this username, authfail.username, is the username that we have in the notable event. Finally, I give it a within time operator with a 1 hour duration. Now, this is a tier 2 rule. You can have multiple tiers. You can have tier 5 analytics. You can decide how you want to leverage those notable events. You can create dashboards out of those notable events. You can have a executive summary of what's going on in your organization. It gives you a good overview of when there's a sudden spike in alerting. All those things, we can leverage notable events. The next option is to directly create an investigation, right? If you have a rule that is giving an actionable confession and you're confident about it, you can create an investigation directly. You can also have two actions over there saying that, hey, create a notable event and also create an investigation. Lastly, you can update lookup tables. You can remove lookup table entries based on your rule conditions, right? So if a rule triggers, update my lookup table. Or if a rule triggers, remove this entry from my lookup table. So we spoke about filters, which includes enrichment using lookups. We spoke about joins, aggregations, and response actions. Notice filters and response actions are highlighted. The reason is filters and response actions are mandatory. Joins and aggregations are optional. You always have to have a filter expression, and you always need a response action in any rule. With that, 3 things we learned today. Firstly, focus on the events of interest. Focus on what you're interested in looking at. This will massively help you scale your rules. We have millions and millions of log messages coming in every hour. There's no need to look at all the million messages. Narrow down to what you're interested in looking at and build a rule off that. Secondly, use scalable correlation rules. When you're under an attack, when you're being attacked with a brute force or denial of service, the last thing you want is your solution to crash because of the DOS attack. You want a scalable solution that can keep up with the attacks. You don't know what the data volume is going to look like when you're under attack. So focus on using scalable correlation rules. Lastly, plan for growth. We don't know the amount of data that's going to be in this world 10 years down the line. You want to build a SIEM solution that can handle the growth of data in this world. Plan for growth. Right? Thank you for joining. And if you have any questions, I will be right here.